Um, Before I get stuck into the next slides, I just wanted to mention how grateful Yarra Energy Foundation is to be working with Flinders Zero Carbon Community and Mornington Peninsula Shire Council and Acacia Energy. And I think it's worth noting that it's rare that you get this confluence of really enthusiastic and supportive people who come together to work on a project. And for me, that's one of the most exciting and interesting thing about community battery projects. And I think it's quite rare. So I just wanted to note for everyone who might not be aware that it's actually a special project in that sense, because as you might be aware, sometimes it can be really difficult to get governments to do things, to get council to act on things, and we're in a situation where everyone is keen to progress this project and make a change. So that in itself is, I think, worth highlighting. The aims of this project are broad, but also in some cases quite specific. One of the functions of community batteries is that they increase the amount of solar that can be installed and exported in a specific part of the network. And that is essential to further decarbonisation of Mornington Peninsula Shire and the energy system as a whole. And as a corollary of that, we do need to increase local storage to best make use of that energy. As I mentioned, the relationship aspect of this project and involving community in the energy transition is one of the key benefits, and that's something that we hope to do, as well as to educate and raise awareness on renewable energy and climate action more broadly. And as Mari mentioned, there's a range of broader system functions and local network functions that community batteries are able to provide that will be essential if we are to transition to a renewable energy system. This slide shows the difference in the generation mix of power at 12 p.m. on the 23rd of November this year and 8 p.m. You can see that during the day there's a boatload of solar, and in the evening it's predominantly brown coal generation that's providing that power. The idea of batteries is to time shift energy, to take energy that's abundant at one time and then provide it at a time later when solar is not as abundant. You can also see that hydroelectric power is providing some generation at that time. Hydro is typically one of the more expensive sources of generation, which is why it's used to meet the evening peak rather than providing power throughout the day. And so one of the functions that we see, not just community batteries, but battery storage in general at scale, is that they actually might be able to help improve the affordability of energy by displacing expensive and sometimes emissions-intensive evening supply. And that applies to the pink section of your bill. So your power bill is actually made up of several different things. The two main costs are generating electricity, but that's less than 50%. There's another, 38% that is network charges. And they're the charges, the costs that are charged to you, the consumer, to ensure the network can continue to run the poles and wires. What we saw with the duck curve is that we have increasingly high peaks in the evening. Now the network is built to supply power at those peaks. The rest of the day, the network is to some extent underutilized. So the more you have a high peak, the more the network charges will increase. So by time shifting energy from the day to the evening at the local level, we're reducing the demand on the network infrastructure in that evening, which should reduce the need to augment the network and associated costs. So that's one of the local functions that has a broader systemic and economic impact on consumers. This is a hypothetical so-called low voltage network. I gather you don't have many apartments in Flinders, but for all intents and purposes, this is a fairly generalizable diagram. We have the generators, transmission, we have zone substations. Eventually the power comes to, you would have seen these pole-top transformers. They're the distribution transformers. That's the main node in a particular neighbourhood, and there are low voltage conductors that emanate from that transformer, and they're all part of one ecosystem. And these transformers have a particular rating, that's how much power can go through them at any one time. And we're seeing some of those transformers are being overutilized. Another thing that happens on these conductors is when you're exporting a lot of solar during the day, if it's not being used, it's actually pushing the voltage up. And it's when the voltage gets too high, that's when solar inverters sometimes trip, they shut down, or they begin derating. And when the solar inverter is derating, it actually reduces the amount of solar power that you're able to access if you have solar panels. So the role of the battery is when it's charging, it's providing a load that ensures that the voltage is not getting too high. The Fitzroy North battery, we run it at half power so that we can run it for longer, and it reduces voltage there by 3 volts at that connection point, and that's quite significant. So that's another one of the functions of community batteries. The reason I'm showing this diagram, apart from that, is that this local network is sort of this is the area from which the battery can absorb solar, and it's the area to which it will discharge. So it's a fairly small geographic area that the battery is actually connected to households. But that doesn't mean that the benefits stop at the boundaries of this network. There are specific technical benefits that are localised, then there are more diffuse benefits around decarbonisation and cost that are essentially, if not regional, then global to the system. I think this should be fairly intuitive, so I won't labour the point, but during the day, you might have solar households who are exporting, you might have businesses or other houses that are consuming, so that's in the blue. When you're exporting, you're typically paid a feed-in tariff, usually at the moment around 5 cents a kilowatt hour, unless you're particularly lucky. Wow, a nice one. I wouldn't change that plan. And the battery is also charging at that time. And if you're running your dishwasher or if the battery is charging, you're purchasing energy from your retailer. The retailer is purchasing that energy from the market. Once you export your energy, in a physical sense, that energy is on this conductor. But from a market perspective, it's just gone into the pool of the market. In the evening, it's essentially the inverse, but no one's able to generate, so the battery is providing that generation. That means the power doesn't have to come through this transformer. So the battery is providing local storage and supply to the neighbourhood. One of the questions we're sometimes asked is, well, why do I have to pay for energy in the evening when I've exported it during the day? Particularly with a battery, if you're storing my energy, why can't I just have it back? The reason is what I just said about the market. You can export your solar energy and you receive an amount paid by your retailer. The retailer then has that energy in their books. Sometimes the value of energy during the day goes into the negative. So they might be paying you 5 cents, and they're actually paying the market for the ability to export that energy because there's so much energy available. Then when they provide energy in the evening, the wholesale price is sometimes far higher than what they're even charging you. So the retailer is balancing out the peaks and the troughs of the wholesale energy market. So the value of your energy that you export during the day is far lower than the value of the energy that you import in the evening, which is why you're not really, economically it doesn't make sense to be able to net out those charges. The other issue is the network tariffs. So the energy, as I said earlier, is only maybe 40% of your bill. Every time you use the network, there are network costs associated with that. And that's something that the battery can't address. So we can come back to this slide if it's not clear, but unfortunately, when the battery is charging, it's charging from the local network, but it's purchasing energy from the market. It's not purchasing from any individual households. So just to summarize, I don't even know if I've mentioned some of these points, but there will be no cost to residents. There are no changes to any retail plans or any feed-in tariffs, and there's no subscriptions in order to participate. The reason I have that in quote marks is because your participation is kind of passive, it's sort of automatic. The battery will be installed and connected to a particular low voltage network. If you're on that low voltage network, you'll be connected to the battery, but you won't notice. If you're not on that low voltage network, you'll be distantly connected to the battery and you still won't notice. So you won't notice. There will not be any material changes, but all of the things that we've mentioned earlier about the energy transition, you will notice if your solar inverter stops derating, and you will notice if United Energy allows you to install more solar that previously you were not able to. So there are material changes that you will notice if you seek them out, but there will not be any additional cost or anything like that. I've mentioned the increased solar hosting capacity. At a local level, depending on where you draw the boundary of the system and which method you use, there will be an increased amount of solar energy in your evening supply because that's what the battery will be discharging. And as I've mentioned, there'll be reduced strain on the network during typically the evening peak when people come home, turn on heaters or air conditioners, things like that. I'm going to talk a little bit about the battery itself. I apologise if it's maybe a bit less engaging than the earlier section, but it is quite important even if it is a bit technical. The battery we've selected for this project is the updated model of what was selected for the PowerCore Tarneep battery and the Fitzroy North battery that Yarra Energy Foundation delivers. It's made by, well, it's called a battery energy storage system because it's a bit more than just a battery. It's made by a company called Pixie, and they're based in Norway. They do have offices in Australia. And it exceeded all the procurement criteria as part of our tender process. And the criteria were informed by the Fitzroy North community engagement process. The battery module manufacturer, which is the actual storage units, are made by Polarium. And within that module, there are battery cells, and they're made by a Swedish company called Northvolt. This is what's in one of the battery cabinets. You can see on this picture, there's a metering and switchboard cabinet. That's the first one you can see. The ones with the cooling systems on their doors, they're the ones that hold the battery modules. The battery cabinets contain three main pieces of equipment. There are smaller power electronics and communications things, but first is the converters. They essentially act as pumps. So they can suck in energy from the grid. And the grid, the power is AC, and then they convert that to DC, which is the form of power that's stored in the battery modules. And then when the battery's discharging, they convert that DC back to AC, direct current versus alternating current. The battery modules are like the water tanks. So the water's being pumped into the tank, and the water can be pumped out of the tank. They're not particularly complex things. I mean, the technology is somewhat advanced, but from a practical perspective, they're not doing a whole lot. The main source of noise and the main parasitic load is the air conditioning units. And they're essentially small reverse cycle air conditioners. So the noise that you would hear when the battery is charging and discharging, which is typically when the air conditioning units are required, it's a bit like standing not too far from a household reverse cycle air conditioner, the heat pump section on the outside. But notice that it's much smaller in scale, but there are 3 of them. Noise was actually one of the key criteria that we looked at. That was something the community in North Fitzroy were particularly interested to know about. The Pixie system had the lowest noise rating of any batteries that were submitted as part of the tender. It's rated at 67 decibels, which is equivalent to standing next to a dishwasher at 1 metre. Some of the other batteries that submitted for that tender had noise ratings more around 90 dB, I think. Now, decibels is a logarithmic scale, which means it's exponential. So the difference between 67 and 90 is massive. I think 90 is approaching jet engine territory. Maybe I'm exaggerating, but tonight I think that's all right. With the addition of baffling, which is becoming available, the noise could be reduced even further down to essentially ambient noise levels. The other element of the battery that was particularly appealing was the aesthetic and the footprint. Now, I'm not going to try and convince you that this is going to win any awards as far as, it's not going in Mona. But at the same time, compared to some of the other batteries, this was definitely the most compact and streamlined, and that opens up, more potential for either artwork or for making it disappear in some way. It's easier to work with, it has better visual amenity from that perspective. Another appealing aspect of this system was that the battery cells are manufactured using 100% fossil-free energy. And 95% of the materials in these cells can be recycled. So we're supporting, in our procurement, we're supporting organisations that are not just committed to turning a profit and to producing technology, they're also thinking closely and proactively about their own contributions to sustainability and to addressing the social impact of the work that they do. They're also building Europe's biggest battery recycling plant, and by 2030 they hope that 50% of their raw materials will be sourced from recycling. I'm trying to think of a way to make this particularly interesting. So the Pixie Power Shaper is rated to the same standard as the iPhone 6 when it comes to ingress of water and dust. So it's not hermetically sealed, but it's very well sealed. That reduces risk in various ways, risk of inundation, things like that. The risk of fire caused by or originating in the battery is considered extremely low. I'll go into why on the next slide, but more likely, if there were to be a fire associated with the battery, it would be derived from an external source. So that's a bigger consideration, I think, for us when it comes to site selection, battery placement, site works. We're more thinking about external risk factors because the risk of the battery itself catching fire on its own is extremely low. The other thing about these types of batteries is they're fundamentally different from lithium-ion batteries that are used in e-scooters, computers, consumer electronics. Not only are they held to far stricter standards and regulations, they're actually a slightly different chemistry as well. And the safety mechanisms that are available to this form of battery far more sophisticated. The polarium modules have sort of at least four if you count the battery management system, safety mechanisms that are overlapping, and that achieves a level of redundancy. So if one were to fail, there would be another 2 or 3 more that would be available to address any issues. If the battery gets too hot, there's a little disc called a positive thermal coefficient device that resists current from flowing in and out of the battery. That allows the cells to cool. There's also a shutdown separator, which is a bit like a valve. Once it reaches a particularly high temperature, it melts, and the two parts of the battery remain physically separated, and it's then essentially impossible for current to flow, and that also prevents overheating. Finally, there's a current interruption device. Rather than responding to temperature, this responds to pressure. So when the pressure reaches a certain point within the battery module, the current interruption device just disconnects the battery, and that's an irreversible process. Finally, the battery management system is sort of the firmware that's installed in these battery modules, and that cuts off the connection at 60 degrees Celsius. So 60 degrees is considered the sort of upper limit of safe operating temperatures for these batteries, but we operate our YEF battery with a ceiling of 45 degrees. So the cooling kicks in far earlier. I just thought I'd mention there's a process called thermal runaway, which has occurred in some batteries. At this chemistry, that occurs at 170 degrees Celsius. So these safety mechanisms are all intended to address any internal risks well in advance of that number. This is a very simplified idea of the site selection process, but it's good to show you where we're at this point. It's important to identify sites early on because you have to consider a range of different criteria. Technical criteria in particular, we need to look at the feasibility of connection to that part of the network because ultimately there's time, energy, resources, cost involved in all of these processes. If we were to begin stakeholder engagement before we even had come up with any options, then I can imagine that, well, you need something to point to in order to engage a community, I think. And this is where we're at now. We have a fair idea of which sites make sense from a technical and physical perspective. We're now at the point where we're opening up this process to the community to get the community's advice on what they feel is what you feel is a feasible and appropriate location for the battery. And we're able to provide a number of discrete options that actually already make sense from a technical perspective. As part of this stakeholder engagement process, we'll be assessing options. And I'll run through some of the considerations that we'll be paying particular attention to when we assess the options. The technical considerations, the specifications of the infrastructure need to be sufficient that the battery is actually allowed to connect by United Energy, has to have enough, essentially, headroom to allow the battery's operation. The demand profile, what we're looking for is that sort of duck curve that Mari showed earlier, where you have low demand in the day and you have peak demand in the evening. that's where the battery can have the most benefit. The mix of customers is related to the demand profile. What we're looking for is a predominantly residential area, because residential areas exhibit that duck curve because of the amount of rooftop solar and the low daytime demand. Obviously, we have to consider the installation method because the level of complexity is proportional to the cost, essentially, and earthing, which I won't go into. This is an area that was highlighted as part of the feasibility study not far from here. The reason this was particularly attractive was because there's such a high solar penetration. We had to go and count again because we thought we may have mucked it up because there was so much solar in this network. Thankfully, we didn't muck it up, so there really is a lot of solar in this part of Flinders. It's also a large network area, so there are a lot of households. That just expands the number of households that we can support in terms of the enabling more solar. It's a residential area, low daytime demand, and we've also assessed the network infrastructure and found that it is appropriate as well. We look at a range of environmental considerations, so there has to be enough space for the battery. We look in particular at fire, flood and traffic risk. We consider the level of disturbance to vegetation, but also if there's an opportunity to enhance vegetation. So as part of the project, it's not just the case that the battery would go in and remove any native vegetation. There may be the option of enhancing the vegetation. Visual impact, I don't think I need to explain that, and the proximity to residents and the implications that has as far as noise, sight lines and land value. I'll just skip past this one, I think. These were the initial proposed sites on King Street. As I mentioned in the previous slide, there's available space. We assessed that there would be low flood, fire and traffic risk. It's on a rise of a hill, so it's protected from inundation. There is vegetation to reduce the visibility of the battery if that's so desired. And given the noise levels of the battery, it's anticipated that there would be very minimal noise impact on surrounding residents. The stakeholder considerations are some of the most important. Once you've established technical feasibility, obviously whoever owns the land has to be supportive of that project. The cost and complexity of the lease, any disruption to existing use of space. So if you were to look at parkland or a community facility, if you go and visit that site on 2 p.m. on a Monday, do you get a good idea of what's happening 7 p.m. on a Saturday? You have to have an understanding of how this space is being used. To what extent is there an opportunity to involve the community and ensure benefits are shared amongst everyone? Is there any impact on accessibility, particularly around footpaths, that sort of thing? And is there the potential for the co-location of EV charging infrastructure? EV charging can essentially expand the storage capacity of the battery by charging during the day. It can enable EV charging in places where otherwise the network could not accommodate it, because it can leverage the capacity of the battery. And it can also enhance the business case of the battery, meaning that potentially some more revenue can flow through to potentially a community benefit fund, or whatever is decided to do with the profits. Opposite is the community launch event for the Fitzroy North battery. It was a freezing wet day that the sun broke out just as we were opening it up, we were grateful for that. As John mentioned, there has been a number of surveys that have gone out that have indicated local support for a community battery project. We'll continue to address the site selection considerations as part of the community engagement process. And Mari is leading this community engagement process with the establishment of a community reference group, which will be involved in some of the negotiable project decisions. I'll leave it there, but I'll be available during the Q&A session. So look forward to chatting some more.